So here we go with 21.2 B and C. Now on Friday we started off learning about the normal curve, and we figured out all the percentages for these things, and we found out how to find our values right here. This was a method called using the 68, 95, 99.7 rule. Now that's not always possible, and that's what we're going to see today. So if a set of data has a mean, mu means mean, of 200, so that means right here, if we have our normal curve, our middle value is 200, and a standard deviation of 20. 1, 2, 3 lines above would be 220, 240, and 260, and 3 lines below would be 180, 160, and 140. Again, taking that mean and subtracting my standard deviation one time, another time, or adding it on this side. So the question asks, what percent of the data is less than 240? And it says use the 68, 95, 99.7 rule. So using the information that I learned yesterday or on Friday, 240 is right here. So to find the percent of the data, I need to add up everything from that location to the left. So I need to add the 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. So let me add that all really quick. So let's see. 0.15 plus 2.35 plus 13.5 plus 34. Now I'm going to hit equals right now because that should equal 50% because that's half my graph. Yep, we're doing good. So plus another 34 plus another 13.5. That means I have 97.5% of the data is less than 240. Now I'm going to show you a different way. What percent of the data is less than 240 using z-scores and the table. Now, you can use z-scores all the time. The 68, 95, 99.7 rule, you really can only use if they're asking about information that's exactly one of those numbers. So I'm going to use the z-score table that happens to work for one of those, or, well, it'll always work for those numbers, but that works for one of those. But when it asks you something about, say maybe they wanted to know something about the number 190, then you have to use z-scores because it doesn't work out to be one of the values on my 68, 95, 99.7 rule. So here's how I find a z-score. I need to take 240, and that's the same one we're finding out there. We're going to compare our answers. I need to convert it to a z-score. Now, I highlighted those on Friday, how to find your z-scores, and I said we'd come back to it today. Now, it happens to be written over here for me also, which is helpful, so let me highlight that so that I've got it fresh in my memory. Now, it's very quick and easy to find a z-score. You take the x value that you're given. In this case, our x value is 240. And I take 240, and I subtract mu, which is the standard deviation. In this problem, the standard, oops, forgot my zero. My standard deviation is 200. And then I divide it by the standard deviation. And the standard deviation for this problem is 20. So that's going to tell me my z-score. So 240 minus 200. 240 minus 200. If I can type it in right, 240 minus 200 is 40 divided by 20 gives me 2. So this one has a z-score of 2. So now you need one of these pink papers. Hopefully the substitute already passed it out. If not, pause the video please and pass that out because they're going to need to look at this pink paper to find their answer. This is a z-score table. And it looks kind of the same on both sides, but there's all of these numbers down the side. And if you notice, these numbers go from 0.0 all the way up to 3.4. The other side goes from 0.0 down to negative 3.4. So one side is a negative side, the other side is a positive side. Now my z-score is a positive number, so I'm going to be looking at the positive side. When you are looking for a z-score, you are actually looking for 2 digits past the decimal. So if I took 2, I'm really looking for 2.00, correct? So looking at here, I need to start off by finding 2.0. The first digit of my decimal will be on this side. That last digit I'm going to be looking for over here. So if I come down here, 2.0, this first one is the 0 column. So this would be 2.00. This next column would be if my z-score was 2.01. This would be 2.02, 2.03, 2.04, and so on. So 2.00 is 0.9772. So I have 0.9772 for 2.00. Now, if I turn that into a percent, that's 97.72%. And the percent that I get off here, you can kind of see here, the percent shows the probability of getting something to the left. So when we were adding these things, less than, we were finding the value and going to the left. So this percentage is good because it's the value going to the left. Now, that right there is not exactly the same as 97.5. Interesting. So, if we use the Z-score table, we get an answer that is very close but not quite exact, because our normal curve using the 68, 95, 99.7 rule isn't exactly precise. It's pretty darn close, and it's good and easy to use when we can. But when we can't, the Z-score table is actually more accurate for us. So, here's what we're going to do. We have math SAT scores information, and we have verbal SAT scores information. We are going to start off on the left side, that is dealing with all of the math information. Then we will go over to the verbal side and do the verbal. So, first thing asks to find the Z-score for a score of 560 in math. So, a score of 560, using my Z-score table, the Z-score would equal that 560, because that's what I'm looking for, the information about, minus the mean. The mean for math is 480. And I would divide that by the standard deviation. The standard deviation for math is 80. So 560 minus 480 is 80. Divided by 80 is 1. And I'm going to call that 1.00 because when I go to my table, I need those 2 digits. All right? So, which score is higher with respect to others who tested? Well, in order to answer that question, I do need to find the Z-score. So let's find the Z-score for verbal really quick. I'm looking for 560 minus the mean, which is 430, over the standard deviation, which is 120. Now, 560 minus 430 is 130 over 120, which gives me 1.08. And which score is higher with respect to the others who tested? Well, a little bit higher Z-score means that, if you look at this graphic right here, the higher the Z-score, remember Z is right here, then the more students that would be the left. So that means that they tested higher. So that would be verbal because the Z-score is higher. Now, remember back here where I said that this was plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations? Well, this is plus 1.08 standard deviations. So it's a part of a standard deviation. It's plus 1. It's a little bit more than plus 1 standard deviation. It's plus an additional 0.08. So that's what our Z-score tells us. It tells us where we should be here. All right, if you scored 450 on the math SAT, again, going back to my Z-score of 1.00, what percent of others scored less than you? Well, that's what my chart tells me, right? My Z-score is 1.00. My Z-score tells me the percentage that that scored less than me. So 1.00 would be 0.8413. Oh, hang on. Ignore that, I did it wrong. If you scored 450 on the math SAT, I was using the Z-score right there. That's not the Z-score because we changed the value. We're not looking at 560, we're looking at 450. So I have to find a new Z-score. So 450 minus the mean, which is 480, divided by the standard deviation, which is 80. That gives me negative 30 over 80, which when I go to my calculator gives me negative 0.38. So I'm going to go, I have to turn over to the negative side. Negative 0.3. And now I have to go over, that's negative 0.30, 1, 2, 3, 4, 5, 6, 7, 8. And sometimes it might be better if you had a ruler or something to follow. But I have 3.3520. Again, that's under the 0.08 column. 0.3, and then the 0.8, or 0.08 I should say. So, what percent scored lower? 35.20% scored less than me if I scored a 450 on the math SAT. What percent of all students who tested scored more than 450? Well, this is the same number, so it's the same Z-score, which means I would get the same value off the table. However, if this is the percent off the table that scored less than me, remember my Z-score shows what scored less than me, how do I find how many people scored more than me? Well, if that's what scored less than me, I take 100% and I subtract that 35.20%, and that leaves me with 100 minus 35.20 gives me 64.80% scored higher than me. So if I need to know higher, I have to subtract the one that I got from my Z-score table from 100. All right, what percent of those who scored between 450, what percent of those who tested scored between 450 and 560? Now this one takes a little bit of thinking. Let's see, between 560, that's based on our number up here, we need to go a little bit further. So 560 gave us a Z-score of 1, and the percentage of people that scored less than 560 based on a Z-score of 1.00 would be 84.13%. 0.8413, which is 84.13%. So let's think about this for a minute. If 560, let's see, if I had a number line that kind of went like this, and all of the students that scored below 560, maybe that's a bad example. Let's use our Z-score table, or let's use our bell curve. So let's say I have my bell curve, and ignoring the values specifically, but knowing that 560 is something over here, right? And then, and I say right because it's more than 84%, so it should be pretty close to the top. And 450 scored higher than 35%, so 450 is somewhere around here. They're asking me, how do I find that value? Well, let's think about this for a minute. 560, the number that I got associated with 560, the 84.13, is all of this included. How would I find just that batch? Well, I would subtract what's less than 450, because if I subtract that part, the remainder will just be what fits between them. So I'm going to take the percentage from 560, and I'm going to subtract the percentage that was less than 450. Less than 450 was 35.20%, and that gave me, or that gives me, if I do that subtraction, 48.98%. So that's pretty close to 50% of your students scored between a 450 and a 560. So between, I take the higher percentage and I subtract the lower percentage. If you wanted to score better than 80% of those who tested, what score would you need to have on the math SAT? So, if I wanted to score better than 80%, I need to find the decimal that corresponds with 80%, or as close as I can get to it. So if I kind of follow the pattern, it looks like a bunch of 9s down here, and then it goes to 8s, and then 7, 6, 5. So where's my 80%? Here's 0.78817979797995 and 8023. Which one of those is closer to 80%? This is 80.23%. That's 79.95%. That right there is what I would say is the closer number to 80%. So I'm going to go backwards with this. This would be corresponding to the decimal 0.84. So let's see. 0.84 has to be the Z-score that I'm looking at. So if I turn this over to give myself a little bit of room here, more than 80%. Okay, so my Z-score, which is found by doing x minus the mean. What was the mean for math for 80? Divided by the standard deviation, which was 80. And the result needs to be that Z-score. Well, how would I solve for x? Well, the first thing I would do is I would multiply by 80. By 80. That means x minus 480 is equal to 0.84 times 80, 67.2. And then I would add 480. And x equals plus 480, 547.2. So, 547.2. Well, I can't really score a 547.2. So, if I wanted to score better than 80% of those who tested, approximately a score of 547 would allow me to do that. If I didn't want to be at 79% and I wanted to be at 80%, sorry, I got a phone call right there. If I was not content with being better than 79% of the students and I needed to be better than 80% or more, I would say 548. So you could say anywhere from a 547 or 548 score would get me scoring higher than or better than 80% of those who tested on the math SAT. Okay, so now let's do the verbal side. If you scored 450 on the verbal SAT, what percent of the others scored less than you? So this is still a 450. We looked at a 450 in math. We're going to look at a 450 on verbal. It's going to be slightly different, though, because the mean verbal score is different and the standard deviation is different. So let's find our Z-score. That would be 450 minus the mean for there is 430 divided by the standard deviation, which is 120. That gives me a Z-score of 450 minus 430 divided by 120, 0.17. So let's go to 0.17. That's on the positive side. 0.1. Going over to the 7 column. 0.5675. So that's 56.75%. And again, that's how many people scored less than the value I just looked up. What percent of all students tested scored more than 450? So just like over here, I have to subtract that from 100%. So 100% minus those that scored less than me leaves me with 56.75. 43.25% scored better than me. So, looks like I did a little bit better on verbal because only 40% scored higher than me, whereas over here 64% scored higher than me. So I'm above average verbal and a little bit below average there. Okay. What percentage of those tested scored between 450 and 560? So this one is like the one over here where I take the higher percentage and I subtract the lower percentage. Now, I don't have a Z-score for I don't have a percentage for 560. I need to go find that. So for 560, I had a Z-score of 1.08. So going to my Z-score table, 1.08 is 0.8599. 0.8599, which is 85.99%. So again, to find the between, I take the higher percent and I subtract the lower percent. So the higher percent came from the 560, the lower percent comes from the 450, that's 43.25%. And when I subtract those, 85.99 minus 43.25, I get 42.74%. So that's how many scored between there. Whoop, I subtracted the wrong number, didn't I? Where did I get 43.25? That's how many scored higher than me, not lower than me. So let's fix that. Got to be careful about these things. So not 43.25. So let's see, 85.99, I'm not subtracting the more than, I'm subtracting the less than, 56.75%. That looks a little better. Okay, so 85.99 minus 56.75, that gives me 29.24%. That's what I was looking for. All right, if you wanted to score better than 80% of those who tested, what score would you need on the verbal SAT? Well, again, score better than 80%. We already found that value. That was right here. That was the 0.84. So I'm going to set 0.84 equal to the Z-score setup for verbal. So that would be x minus not 480, but 430 over the standard deviation, which is 120. So I would multiply both sides by 120. And 120 times 0.84 gives me 100.8 equals x minus 430. Add 430. And I get x equals 530. So I would say if I needed to score higher than 80%, then on the verbal, I need to score a 530, probably a 531, that would round up to, in order to score higher than 80%. So again, we have two different processes. We have the 68, 95, 99.7 rule. That's what you did on last night's homework, and that's generally a little bit easier. However, if you want to be more accurate, you do need to use the Z-score table and look up your numbers there. Okay? Make sure you keep your Z-score table. This one right here, you're going to need it. I have moved your quiz from tomorrow back to Wednesday, just because I'm going to need to be able to go over this with you tomorrow, because I believe your quiz does have a few questions about finding the Z-score. So I will be back tomorrow, and I'll see you then.